To predict the formula of an ionic compound, you really just need to be making sure that the charge of the positive ion, the cation, is balanced out by the charge of the negative ion, which is the anion. So ordinarily, the cation will be formed by the metal, and the anion will be formed from the non-metal. So you need to get to know your way around the periodic table, okay? So if a metal is in group 1, for instance, it is always going to form a +1 charge, okay? That is a given, okay? So if it's lithium or sodium, potassium, whatever it is, it's always going to form a +1 charge. If it is a group 2 metal, an alkaline earth metal, it's always going to form a +2 charge. This is something you can rely on. Scandium and yttrium will form +3, but apart from that, in the transition metals, you really don't know until you get to zinc, because zinc is usually +2. That's a bit of an unusual one, okay? In the rest of the transition elements in the middle, I would not expect you to predict what ionic compound was found unless you were told what the charge on that transition metal cation is. So that leads us to the non-metals, okay? So again, elemental monoatomic non-metal anions will always form anions with predictable charges. So noble gases don't want to form anions at all. The halogens in group 17 will always form a -1. Group 16 will always form a -2 if my fingers hit the right button. Group 15, the nitrogens, will always form -3. Okay, so you can use this to work out what charges should form in your cation and anion, and therefore write the electrically balanced, no overall charge, empirical formula, which would be the lowest whole number ratio. So like between magnesium and chlorine, we can see magnesium is in group 2, so it's going to form a 2+ cation, and chlorine is in group 17, so it will form a 1- anion. So it's going to take 2 chlorine anions to balance out that Mg2+. So if you're doing a very quick, like, does something form an ionic compound? If it's a metal plus a non-metal, yes, it will form an ionic compound. If it's a non-metal plus another non-metal, that will form a molecular compound. And if it's 2 metals, then it's going to form an alloy, which is something that we are not covering in this course. So that would not be an ionic compound. Okay, so the empirical formula then of magnesium chloride should be MgCl subscript 2. Okay, so bromine and lithium, find them in the periodic table. Bromine is over here in group 17, so it's going to form a Br- ion. Look at them, sneaky, giving you an anion first, okay? And then lithium is over here in group 1, so forms Li+. The convention is always to write the metal first, okay? We read left to right, periodic table, metals on the left, non-metals on the right. So that'll be LiBr. It's a 1-to-1 ratio between those two. So yes, it forms an ionic compound, and I'd predict the formula be LiBr, because +1 -1 cancels out. Okay, so rubidium and strontium. Rubidium's a group 1 metal, strontium's a group 2 metal. Those are both metals. They will not form an ionic compound. They'll form an alloy. And then finally, rubidium and chlorine. Rubidium's in group 1, chlorine's in group 17. So rubidium will form the rubidium +1 cation. Chlorine will form the Cl- the chloride ion, and they'll balance each other out in a 1-to-1 ratio. So rubidium chloride would look a little something like this. So yes, that is ionic, a metal and a non-metal, and the ratio that will balance out will be 1-to-1. Okay, let's do another one of these and see what we got. All right, just scrub these guys real quick. Find my periodic table again. Boom, there it is. Okay, so sulfur and strontium. So sulfur is a non-metal over here in group 16, the chalcogens. So it will form the sulfide, S2- ion. Strontium is in group 2, the alkaline earth metal. So it forms a strontium 2+ cation. So -2 + 2 is going to cancel out or give me strontium sulfide like that. So yes, that's an ionic compound. The empirical formula should be SRS. What about iodine and lithium? Well, iodine is in group 17, so it forms the I- anion. Lithium is in group 1 here, so forms a +1 cation. So we would expect them to combine in a 1-to-1 ratio to be charge neutral, so lithium iodide would look a little something like this. Lithium iodide. depending on what font you get. Depends if you got the serif on the I or not. So barium and lithium. Barium is a group 2 metal. Lithium is a group 1 metal. So 2 metals cannot form an ionic compound or a molecular compound. So no, it does not form an ionic compound. And then finally, strontium and iodine. Strontium's in group 2, so that'd be strontium 2 plus. And iodine is in group 17 here, so that'd be I minus. So it's going to take 2 iodine ions to balance out the 1 strontium 2 plus, so that'll be SrI2 will be the formula there. All right, the more you practice, the better with those. You just need to make sure that your empirical formula will give you an ionic compound that has no overall charge, okay? The sums of the charges should add to 0.